Hey guys, it's Mrs. McDaniel here to teach 9.6, which I do have an error at the top of this. It says logarithmic application problems. It should be graphing logarithms, so I apologize, but it's just up here in the corner, which is really going to make no difference. So it just has the wrong heading. I am going to go along and we're going to talk about graphing logarithms. The function y equals log base b of x, or b is not 1. It's called a logarithmic function, and it represents the parent graph of the logarithmic function. And as you guys can see down here, the logarithmic function is actually kind of the opposite of an exponential function. It kind of turns the graph on its side. So standard form of a logarithmic function looks like this. F of x equals log b of x. Logarithms are inverse or opposites to exponential equations, so everything is switched. All logarithmic functions have a vertical asymptote, so this one's going to be a little bit different. Let's put a T there. Asymptote. When the logarithmic function is not shifted left or right, the vertical asymptote will be x equals 0. And what's weird about this is we're always used to the domain being negative infinity to infinity. That's actually the range this time. Our range will be negative infinity to infinity because you can plug in any value for y, but the domain will change based on whether or not the graph is shifted. And this was a mistake, not up or down, but right or left, because the graph is turned on its side. So that will be the change here today. So I'm going to show you guys how to do these. We are going to do these. We're going to start doing these by just plugging in whatever numbers we would like to plug in. I'm going to talk to you about what's best to plug in. The transformation for this one will be none because you guys can see there's nothing added or subtracted. And as a review, just up here, remember a positive h will shift left h, and that's kind of backwards from what we think. And a negative h will shift the graph right h. So that's kind of, again, h units backwards from what we think. And then the k will shift, a positive k will shift it up k units, and then a negative k will shift it down k units. Okay, so my bad, didn't start with that, went back, but this transformation has no transformation. The asymptote here is going to be x equals 0 since there's nothing added on or subtracted on the x value. We'll get back to the domain and range, but I'm going to talk about some values that you can plug in to do this. Remember, you cannot put into your calculator log base 5, so we are going to have to change this to the change of base, which would be actually log x divided by log 5. Also, you guys, if at all possible, you want to use the number that the base is so that we can get log 5 of 5, because log 5 of 5 is just 1. And that is because the equation, the exponential equation is 5 of x equals 1, or 5 to the x power equals 1. I was trying to write that over here and then I got mixed up. So 5 to the y power is actually equal to x here. And so that means that 5 to the 1 power will give us 5. So you want to use 5 because the base is 5. So again, for change of base, I did log 5 divided by log 5 in my calculator, and that got me 1. And then now I'm going to pick a couple more numbers. It's a good idea to get you want to get 1 as well, because when you do log 1 divided by log 5, that's just going to give you 1, because 5 to the first power gives you 5. So you also wanted to use 1. And actually, I lied about that. If the x value is 1, and I apologize, if the x value is 1, basically here, you're asking yourself, what power would this be? And that would actually be the 0 power. So this should be 0 over here. Let me see if I can get my drawing tools up. This will get us 0. So log 1 divided by log 5, when you put it in your calculator, is 0. And then the last one I'm going to do is I'm going to do a really large number, the largest on the graph, which is 9. So I'm going to do log base 9 divided by log base 5, and that gets me about 1.4. And when I go to graph these, it's going to be on its side. Remember, the asymptote is going to be this line right here. I'm putting that in as a pink line. And then I'm going to plug in my values. So I'm going to go over 1 up 0, which is right here. I'm going to go over 5 up 1, which is right here. Ugh, that wasn't a really great dot. It's really sometimes hard to do these on here. Over 5 up 1 is right about there. And then over 9 up 1.4 is really just halfway in between those. So you can see, and then this will approach 0. So we can plug in like a very low number and it'll keep approaching 0. So that is the picture. The range, like I said, is negative infinity to infinity, because you can plug in any y value you want, positive or negative for the exponent, but you're only going to get, your domain is going to be 0 to infinity. And that is because we are going this direction. That is 0 from 0 to the right, which is 0 to infinity. Okay, let's see if I can do a better job of explaining this one a little bit. This is actually very similar, because it is basically, if you rewrote it as an exponent, it would be 3 to the y power equals x. And if we wrote that change of base, it would be log of x over log of 3. And that's what we're going to do every time we plug in a number. Remember, I told you guys that 1 would be a good choice. Also, 3 is a good choice on this one, because it's the same as the base we're in. So we want to use that. And then we're going to use a big number at the end, which is 9. So if you do log 3 divided by log 3, that will give you 0. I did it again, not 1. 0. Log, nope, I was right. Log 3 divided by log 3 is 1. God, I gotta put those in my calculator. So log 3 divided by log 3 is 1. And that's the middle one. I was thinking I was doing log 1 divided by log 3, because naturally I would start with that top one, but I didn't. And that is 0, because 3 to the 0 power does give you 1. So this is 0. And then if I do log 9 divided by log 3, this actually comes out nice, because 3 to the second power does give you 9. So this does end up being 2. Your exponent would be 2. So we got some nice numbers on this one. There is still no transformation here. The asymptote will still be x equals 0. So it's still this one right here. And then if I go to graph it, it'll be over 1 up 0, so right there. Over 3 up 1, so right about here. And over 9 up 2, so right about here. And then it will continue approaching 0 right down here. Range, because we can put in any value we want for y. That's going to be negative infinity to infinity. And then our domain will just be 0, where our asymptote is, to infinity, because it is moving to the right. Okay, moving on down. Now these have some transformations, which makes them a little bit more difficult, but not bad. Um, this has a transformation of 5 down and 2 right. This right here is going to be your asymptote. Remember on exponents, this was your asymptote? Okay, I'm going to undo that, but this time now that it is, the function is based off that x value, your asymptote is going to be that value, that 2. Now remember, that shifts it left, so it's actually going to be y is equal to -2, which is going to make it roll through right here. I'll go ahead and put that in. So there's that asymptote. Then we're going to plug in some values. Now, values that we can plug in that are good. I mean, you can do anything you want, but it is great if what is in the parentheses is a 1. Because on this one, I'm going to show you guys, I'm going to put in a -1 so that we have, when we plug in -1 here, we get -1 plus 2. So it basically becomes log 1. Hi. Sorry. Sorry, I got interrupted. I'm going to finish making this video. So I'm going to get log 1. So I'm going to do log 1 over log 6. And then after I do that, I'm going to subtract 5. Well, log 1 over log 6, if you put it in your calculator, is 0, and 0 minus 5 is -5. So that is how I'm getting that number. Also, it is a really good idea if I get the same number as the base, and the same number of the base is 6. So what I need to plug in for x is 4, so that I get 4 plus 2, so I get log 6 of log 6. Log 6 of 6. And then that way I can rewrite this as log 6 over log 6 and then minus 5. And that equals -4. So I plugged in +4, I got out -4. Then we like to try a 9. Basically, we like to plug in a 9. But remember, when we plug in 9 here, it's going to get us 9 plus 2, which is 11. So it's going to be log 11 over log 6 when we do that change of base formula. And then we're going to subtract 5, and we get -3.7. So I plugged in 9, and I got -3.7. So I'm going to go ahead and graph these. When I go left 1, I go down 5. When I go right 4, I go down 4. So that's about here. And then when I go right 9, I go down about -3.7, which is almost 4. So this right here kind of looks like a straight line, but it's not. And then this would come over here. Boy, that does not look like a good graph. But it should look something like that. The domain and range. The range is -infinity to infinity because you can plug in any value you want. The domain will be from that asymptote to positive infinity because it's going to the right. All right, last but not least, we're going to do this one. Sorry, I moved that graph. So what we're going to do on this one is we're going to plug in some values. Again, you don't want to plug something in there that gives you 0. So don't plug in 2 because ln of 2 will give you an error. So this graph has shifted to the right. So you can't do 2 because that's actually where the asymptote is. So the asymptote is at x equals 2. So if you put 2 in, you're going to get an error in your calculator. It's going to tell you it won't work because the graph is approaching that line. So we need to go larger than 2. We would like a 9 for sure. And the other one I would like to get a log of 1. So I'm going to do a 3. So I'm just going to do a 3, 5, and 9 just because they're kind of spread out. So I'm going to do ln of 3 minus 2, which is basically ln of 1, which gets me 1. when you do that, because it's basically e raised to the first power gives you e. So that's going to give you 1. And then the other ones, I'm just going to plug them into my calculator. So ln 5 minus 2. When I did that, it's basically ln 3, and I got 1.1. So it just moved a little bit. And then I'm going to do ln 9 minus 2. And I basically get ln of 7, which is about 1.9. So I'm going to go over 3 up 1. I'm going to go over 5 up 1.1. And then I'm going to go over 9 up 1.9. So again, they're not very far apart from each other, but this is what it should kind of look like. Again, my graph doesn't look great. It's not an L. It really should be curved. Mine looks kind of straight, but it really should be curving. And then the domain on this one will be from 2 to infinity because it's 2 to the right. And then the range will be negative infinity to infinity. Okay. Also, guys, we're going to talk a little bit about how you can use your graphing calculator to help you do these a little bit tomorrow. So that might help some of you. And if you need anything, please come see me. Thanks. Bye.